Good morning. My topic for seminar presentation is OLED. OLED stands for Organic Light Emitting Diode. In this presentation, we will be covering introduction part, what is an OLED, its history, features, working principle, manufacturing, advantages and disadvantages. After that, we'll be discussing its future scope and references. Moving on to introduction part. OLED stands for Organic Light Emitting Diode. It is an emerging technology for displays in devices right now. It is based on the principle of electroluminescence, that is, electric current is supplied to the OLED cell and in turn it releases energy in the form of light. It offers brighter, thinner, high contrast, flexible displays to us. So what is basically an OLED? It is a solid state device composed of thin films of organic molecules that is about 100 to 500 nanometers thick. The light is emitted when electric current is applied to them. They doesn't require any backlight, that is, they are self-emitting. Next, they are made of carbon and hydrogen, hence they are composed of organic polymers or molecules. Now, history of OLED. The first OLED device was developed by Stephen Wanks-Like in Eastman Kodak Company in 1987. After that, in 1996, it was commercialized. In 2000, many companies like Motorola and LG announced their displays. In 2001, Sony developed its first full-color OLED display. In 2002, approximately 3.5 million passive matrix OLED displays were sold, and after that, 10 million were sold in 2003. Now, in 2010 and 11, many companies announced their AMOLED displays, which is currently being used in smartphones. After that, many developments have been taken place. Now, its features: it is flexible well enough. It is an emissive technology. It doesn't require any backlight to function. It is lightweight and thin. It consumes very much less power, hence low power consumption. It has higher contrast, brighter and perfect displays from all angles, viewing up to 170 degrees. Okay. Next, structure of OLED. It consists of cathode and anode. After anode, below anode we have substrate, and between these cathode and anode we have two layers, that is emissive layer and a conductive layer, which acts on the principle of electroluminescence. Now, how OLED works? It simply works on the principle of electroluminescence, that is, when electric current is applied across the two layers of emissive and conducive layers of OLED, it starts emitting light. So electric current flows from the cathode to the anode through the organic layers, giving electrons to the emissive layer and removing electrons from the conducive layer. So holes starts forming around the conducive layer. After that, removing of electrons produces holes in the conducive layer, which in turn, when electrons fall from emissive layer to the conducive layer, the energy is released in the form of light, which may be red, blue, white, green, etc., depending upon the wavelength. Now, its working principle. A voltage is applied across the anode and cathode. Current flows from cathode to anode through the organic layers, that is emissive and conducive layers. Electrons flow to emissive layer from the cathode. The electrons start flowing towards the emissive layer through the cathode. Cathode start collecting electrons from the lowermost layer, that is conducive layer. Okay, and holes are formed in emissive layer, electron and hole combined, and light is emitted. Now, manufacturing of OLED. It is manufactured using three different processes that are used in industrial environment. That is, number one, vacuum deposition or vacuum thermal evaporation, VDE, organic vapor phase deposition or OVPD, and inkjet printing, which uses piezo inkjet printers to print organic polymers on nanoscale. Now, types of OLED. There are approximately 6 types of OLED right now, that is passive matrix OLED, active matrix OLED, and transparent OLED, top emitting OLED, foldable OLED, and white OLED. Moving on to passive matrix OLED. It consists of perpendicular cathode and anode strips orientation, and light is emitted at intersection of pixels. It requires external circuitry to control this, to require the turn and on of pixels. External circuitry acts as an interface between pixels. Now, it has large power consumption and it is only used for 1 to 3 inches of displays. Next is active matrix AMOLED. Active matrix OLED or AMOLED displays, which is used in smartphones. It consists of full layers of cathode and anode organic molecules. Thin films of transistor matrix on top of anode is used. Internal circuitry is to determine which pixel to turn on or off. Less power is consumed than PMOLED display in this case, and it is used for larger displays like smartphones. Next we have transparent OLED. Transparent OLED consists of substrate which is transparent and cathode and anode. Bidirectional emission of light takes place, and it is just like passive or active matrix OLED, which means pixels are needed to be turned on or off depending upon the external circuitry. Now, transparent projector screen is an example of this display. Now, top emitting OLED, or these are non-transparent or reflective substrates. Transparent cathode is used in this case, and below that we have reflective substrate which reflects light and is used for the devices such as presentation projectors, etc. It can also be used in smart card displays. Now moving on to further topic, foldable OLED, which is currently used in many phones like Motorola Razr. It consists of flexible metallic foil or plastic substrates which is sandwiched on top of this, and it is lightweight and durable, and it reduces display breaking. It is just like clothing OLED. Now moving on to white OLED, it reduces power consumption by very much amount. It emits bright white light, and it can replace fluorescent lights which consumes a lot of power. So true color qualities are displayed by this OLED device. Now advantages of OLED: they are very thin, approximately about 1 mm thick, low power consumption and higher brightness, higher contrast ratio about 10th observation 1, which is not in case of LCD, and wide viewing angle supporting up to 170 degrees without loss of emission. Now foldable display panels are most examples of OLED, and lack of poisonous mercury, which is used in other displays like LCD, CRT, etc. Now applications of OLED. Major applications of OLED technology includes mobile phones, OLED screens, TV, and smartwatches, etc. Now advantages of OLED displays over TFT LCD displays. That is higher contrast ratio than TFT LCD displays, better impression for higher brightness. Here in the above picture we can see which is composed of LED and OLED device, and we can clearly see the amount of contrast ratio on both of the devices. OLED wins in this case. Now disadvantages of OLED: it has very limited lifetime span of colors. Example, white red has only 46,230 lakh hours, and it is about 5.25 years of support, and blue has only 14,000 hours of lifespan. Also, it is expensive and susceptible to water, and it is not possible to overcome multi-billion-dollar market which is LCD market right now. Now conclusion: limited use caused by degradation of materials, because less materials are required to the production of OLED, so limited use of materials is caused and hence degradation is reduced. OLED will replace current and LED and LCD technologies in future, of course, and it is expensive right now, but it will be, with the evolution technology, it will be cheaper. Flexibility and thinness will enable many applications of OLED. Here are some references from which we can study about OLED more. Thank you.